All right, let's finish up talking about nomenclature for alcohols by looking at the situation where you have more than one hydroxyl group. If you have two of them, it's a diol, also known as a glycol, using the common nomenclature. So IUPAC would call this 1,2-ethane diol. The common way of naming it would be ethylene glycol. Just as a CH2 is a methylene, a CH2CH2 is an ethylene. And we're going to find out these are unfortunate names because in a couple of minutes we're going to be naming alkenes, and alkenes end in ene. So the fact that this is ethylene glycol, but there's no double bond, is confusing. All right, so here would be 1,2,3, 1,3 propane triol or trimethylene glycol. Let's see. Also note that if you have three OHs on your parent chain, that would be a triol, or in the common name, that would be a glycerol. Okay, let's look at cyclic compounds. Start with our monocyclic compounds, the only ones we're really going to look at. If you have three carbons, well, three carbons, is a propane, but because they make a cyclic compound, it's a cyclopropane. So this square looking here is actually cyclobutane, cyclopentane, cyclohexane. All right. If you have one substituent, you just name that substituent. So here's an isopropyl group, CH3CHCH3, an isopropyl group on a hexane, isopropyl hexane. If you have two substituents on your cyclic ring, you just name them alphabetically. We've got an ethyl here, we've got a methyl here. So we're going to call the carbon with the ethyl, since E comes before M, the carbon with the ethyl is going to be 1. So this would be 1, 2, 3, 1, 3, or 1 ethyl, 3 methyl cyclohexane. All right. If you have three substituents, you go for the lowest numbers of the locants, meaning we don't really go by alphabetical here unless we have to. We are going by this is on carbon number 1, this is on carbon 2, 3, 4, 1 plus 2 plus 4, 4, 5, 6, 7. That is 7. If we numbered it any other way, when we add up the locant numbers, we'll get numbers larger than 7. If you started here, it would be 1, 2, 3, and 4. 3 and 4 is 7 plus 1 is 8. So you start up here, 1, 2, 3, 4, to give the smallest sum of the locant numbers. Now, something else to remember, recall how alcohols are very important. And so when you do have an alcohol on your ring, that will be carbon number 1. The carbon containing the OH is carbon number 1 because alcohols are the parent molecule. So this is a cyclohexanol with a methyl on carbon 2 because carbon containing the OH is carbon number 1. So this is carbon 2 right here, 2-methyl cyclohexanol. All right. And when we're looking at these, when we're naming them, note that you have alkyl cycloalkanes like this. You can have halocycloalkanes like chlorohexane or chloropentane. And this would be an alkyl cyclohexanol, cycloalkanol. It's an alkyl group here, cycloalkane all. This is just another way of saying that if it's an alkyl group, then the parent is the cycloalkane. If there's a halogen group, the parent is the cycloalkane. If there's an OH on it, the parent is the cycloalkanol. It's the alcohol. All right. Now, the other thing with these ring systems is occasionally the ring is not the biggest part of the molecule. For example, if we look right here, we've got a cyclobutane ring, but 1, 2, 3, 4, 5 carbons. We can argue that a 5-carbon chain is more important. It is larger than the cyclobutane. So we'll call our parent the pentane, and on carbon number 1 in the pentane is a cyclobutyl group. So this would be 1, don't forget the dash here, 1-cyclobutylpentane. And here's another situation where, okay, well, we've got 2 cyclohexane rings. Let's just say, okay, let's just call it a dicyclohexyl on this propane. Even though the cyclohexanes are bigger than the propane, it's just easier to name it 1,3-dicyclohexyl propane. All right, some people go into the naming of bicyclic compounds. If you're interested in naming bicyclic compounds, things that look like this, read this. We will not be covering that this semester, though, so don't worry about bicyclic compounds. All right, nomenclature of alkenes and alkynes. The good news is if you know how to name alkenes, you're most of the way there. The only major difference is the alkene is the parent or the alkyne is the parent. And very important, the longest chain must have both carbons of the alkene or both carbons of the alkyne in it. Even though there might be a longer chain that does not include both carbons of the alkene, the parent is the alkene, so both carbons must be in there. With small alkenes, note 2 carbons, so if it was an alkane, it would be ethane. IUPAC will call this ethene. The common name is ethylene here. CH2 is an ethylene, whether there's a single bond or a double bond. All right, this would be propene. See, 3 carbons is propene. For the IUPAC, common is propylene, which means this right here, if we say, okay, naming this according to IUPAC rules, we've got to find the longest carbon chain that contains both carbons of the double bond. So 1, 2, 3. We give the carbon of the double bonds the lowest numbers possible. So good news, we can call this one 1 and this one 2. So there's a methyl group off 2, 2-methylpropene. The common name for this would be isobutylene. You know, truthfully, I like the IUPAC name because this tells me exactly the structure of the molecule. All right, so let's review these rules that I've said. The longest chain that contains both carbons of the double bond, it ends in -ene. The number at the end closest to the carbons of the double bond, those 2 carbons must get the lowest numbers possible. Give the carbon number for substituents, and if you have a cycloalkene, 1 and 2 are always going to be in the ring if you got a cycloalkene. And then you try to give the other substituents their lowest numbers. So let's look at some examples of this. If we look at this beast right here, we can say, all right, we've got an alkene double bond, so we need to make the 2 carbons the lowest number possible. If we numbered from this end, they would be 1, 2, 3, 4, and 5. Number from this end, they're 2 and 3. So we're going to number the carbons 1, 2, 3, 4, 5, 6 this way. Note we've got a methyl on 2, a methyl on 5. So this is 2,5-dimethyl 2-hexene. 2,5-dimethyl 2-hexene, and hexene because of the 6 carbons in our longest chain here. Note that IUPAC has decided to change this to 2,5-dimethyl hex 2-ene to put the 2 next to the ene, just as the 2,5 is next to the dimethyl. I like the 2-hexene way of naming it now, but your kids are going to think that's weird. This is going to make more sense to them. All right. So for label numbering this way, note we've got a cyclohexene. Since the double bond is in the ring, one of the carbons is carbon 1, the other is carbon 2. And then this is 3, 4, 5, 3,5-dimethyl cyclohexene. All right, an interesting situation. What if you have an OH and a carbon-carbon double bond in the same molecule? Well, we call these alkenols. And the truth is the parent is the alcohol, but you must include both carbons of the alkene in the longest chain. But the parent is an alcohol, so the OH, the carbon with the OH, gets the smallest number. So here we're going to number 1, 2, 3, 4, 5, making sure we give the carbon containing the OH the smallest number, and that both carbons in the double bond are part of that longest chain. And so we've got a methyl on 4, so this is 4-methyl 3-pentene 2-ol. Sounds a little weird, but that's how we have to do it because it's an alkenol. We need to indicate that we got 3-pentene and 2 alcohol on 2, 4-methyl 3-pentene 2-ol, or 4-methylpent 3N2-ol. Lots of people are going to this way because, 4-methylpent, 5 carbons, 3N means the alkene is on carbon 3, 2-ol means the alcohol is on carbon 2. Okay. One last example, if you are naming these, what would you name this? Let's look at this guy right here. What if you wanted to name this beast? How would you name it? And this one's actually kind of tricky because we need the longest chain, but recall we've got an alcohol and a carbon-carbon double bond, so our longest chain must contain the carbon containing the OH, and it must contain both carbons of the double bond. We need to give the carbon containing the OH the smallest number, so this would be carbon 1 here, 1, 2, 3, 4. But where do we start numbering after that, after we've gotten that 4? Let's take a look. 1, 2, 3, 4. Since we must contain both carbons of the carbon-carbon double bond, the next carbon, 5, is up here. 1, 2, 3, 4, 5. This is a 5-carbon group. This is a pentyl group. And that's the way this one has to be named. It will be 4-pentyl, because the pentyl group's on carbon 4, 4-pentyl. What else do we have? 4-pentyl, 5 carbons in the longest chain, and the double bond is I'll start on carbon 4, 4-pentyl, 4-pentene 2-ol. Pentyl group on carbon 4. The double bond starts on carbon 4. That's our 4-pentene because there's 5 carbons in that chain. Second carbon has the alcohol. And no, why didn't we number it 1, 2, 3, 4, 5, 6, 7, 8, 9? That's a much longer chain. Than 9 is much longer than 5. Why don't we name it that way? Because we have to have both carbons of the double bond in that longest chain. In our parent has to have both carbons of the double bond. That's why we would do it that way. All right. Other frequently found things with double bonds, just a CH2 double bond CH is called a vinyl group. A CH2 double bond CH, CH2 is called an allyl group, and we'll see these a lot more in organic too. And so we're not going to cover this too much, but you could call this bromoethene or vinyl bromide because the Br is on a vinyl group. And this is a chlorine on an allyl group, so you could call this allyl chloride, or IUPAC 3-chloropropene. 1, 2, 3. Give the carbon with starting the double bond the lowest number. 1, 2. So it's carbon 1. So it's a propene. 1, 2, 3. 3-chloropropene. All right. Cool. This one, that's a little advanced. We won't worry about these right now. Recall cis and trans isomers, where if you have a molecule, you have our molecule a double bond, and we've drawn it out, and we can draw a line down through the double bond, and you see we've got a hydrogen on this side and a hydrogen on the other side. then we can name this as the trans molecule because the two hydrogens are on opposite sides of that line. So we put that before the name. This would be trans 2-butene when you can name cis and trans. Note, there are situations, for example, if we look at this molecule right here, we cannot name this cis or trans. Unfortunately, we cannot do that because to have cis or trans in the actual name of the molecule, it must be a situation where there are two hydrogens, one on each carbon of the double bond. You have to have a hydrogen and a hydrogen here to have it trans, to have that trans in the name. Since there's no hydrogens on this carbon right here, we cannot name this trans or cis. Don't worry. In a few chapters, we're going to learn how to name this better. All right. So that's alkenes. Alkynes is just like alkenes, except we end in "ine." And note the OH, alcohol, has precedence over the triple bond, just like it has precedence over the double bond. So this right here, 1, 2, 3, 4, 5 carbons. We'll start numbering from this end because it's closer to the triple bond. So the triple bond starts on carbon 2, 2-pentyne. Yep. All right, and here are some other names down here. Note if we have a triple bond and an alcohol, this will be carbon number 1 because it is more important. All right. So let's just finish up this video real quick because talking about physical properties, and we've been looking at this solubility and whatnot, but let's go over it. Doesn't hurt to go over it again. Physical properties of alkanes and cycloalkanes. Note their boiling points are lower than water. They all tend to have lower boiling points than water, but the longer the chain, the higher the boiling point because more van der Waals forces and all that type of good stuff. As we said, more branches means lower boiling point because of the surface area. A cycloalkane is about the same melt boiling point as an unbranched alkane. So cyclohexane and hexane have roughly the same boiling point. We talked about melting points already. Density, note we've seen this in lab, the density of alkanes, they have the lowest density of all organic molecules. It's less than 1. It's about 0.6. So 0.6 to 0.7 or so, that's your density of alkanes. And solubility, they are insoluble in water. Just a rehash of things we've already learned from lecture and lab. All right, so in the next video, we will continue on with this chapter and look at bond rotation.